Somewhere beneath the silt of the Nile, or scattered as firewood across 1,000 ancient hearths, lies the memory of a ship that carried a mountain. Not a mountain of grain or of timber or of tribute, but a mountain of stone, quarried whole from the red granite of the south, shaped into two vast needles of rock, each one heavier than 100 loaded wagons, each one longer than most of the houses that lined the river. The ship built to carry them has no name that has come down to us. It has no wreck resting on the riverbed, with its ribs still curved against the current. It has no timber in a museum case, no plank, no peg, no fragment of rope. What it has, instead, is a picture on the wall of a temple carved into a cliff on the west bank at Thebes. An unknown craftsman cut the outline of this ship into limestone more than 3,400 years ago, and there it remains, low and long and impossibly wide, with two great obelisks lying end to end upon its deck. And before it, straining at the tow lines, a fleet of boats so numerous that the artist had to stack them in rows to fit them all onto the wall. That carving is the only reason we know the ship existed at all. It is a ship known entirely from its portrait, and for as long as people have looked at that portrait, they have argued about whether such a vessel could have floated. This is the story of that barge, and of the woman who ordered it, and of the stone it was built to carry. It is a story that begins in a quarry in the far south of Egypt, where a seam of granite ran deep beneath the sand, and where men with hard black stones in their hands spent months pounding a channel into rock that no copper tool could bite. It moves down the river, past temples and villages, and the long green ribbon of cultivated land that clung to the water on either side, past the flood and the falling of the flood, past the shrines of gods whose names were already ancient when the ship was built. It ends at Thebes, in the great house of the god Amun, where two obelisks were raised upright toward the sun, their tips sheathed in a bright alloy of gold and silver, so that when the dawn came, they would catch the first light and throw it back across the roofs of the city. One of those obelisks is still standing. It has stood in the same place, in the same posture, for something close to 3,500 years. It has watched the end of the dynasty that raised it, the coming of the Persians, the coming of Alexander, the coming of Rome, the rise and fall of empires that had not yet been imagined when it was cut from the ground. It is, by most reckonings, the tallest ancient obelisk still standing anywhere in Egypt, rising to somewhere near 28.5 meters, which is to say a shaft of solid granite taller than a modern building of 9 or 10 stories, and weighing, according to the estimates that engineers have made, somewhere between 300 and 350 tons. Its companion has fallen. It lies broken near the sacred lake at Karnak, one great section of it resting on its side, worn smooth by centuries of hands and weather, and visitors walk past it every day without quite understanding that they are looking at half of one of the heaviest objects ever moved by human beings before the age of steam. And to move them, someone had to build a ship. That is the fact worth holding on to, the fact around which everything else in this story arranges itself. The obelisks did not walk to Thebes. They did not roll. There was no road in ancient Egypt capable of bearing that weight for the length of that journey, and there was no need for one because Egypt had something better than a road. It had the river. The Nile ran the length of the country like a spine, and the current carried you north while the prevailing wind carried you south. And for 4,000 years, the Egyptians had understood that anything heavy should, if at all possible, be made to float. Grain floated, cattle floated, cedar from the coast of what is now Lebanon floated. Limestone blocks for the pyramids had floated centuries before down from the quarries at Tura, and so when a queen who called herself king decided that she would give her god a pair of obelisks larger than any that had been raised before her, The question was never whether the stone would travel by water. The question was, what kind of vessel could carry a burden like that without simply folding in the middle and going to the bottom? The answer, apparently, was a barge so wide and so long that its dimensions have troubled naval architects for 100 years. The carving at Deir el-Bahari shows a hull of extraordinary proportions, flat and broad, with a great cable running from bow to stern above the deck, and the two obelisks laid nose to tail along its length like arrows in a quiver. Scholars who have tried to reconstruct it from the relief and from the known weight of the stone have proposed figures that range widely. Some have suggested a hull of around 63 meters in length and 21 in breadth. Others, working from the assumption that both obelisks traveled together, have argued for something far larger, perhaps 90 meters or more from bow to stern and 30 across the beam, with a displacement, once the stone was aboard, of well over 1,000 tons. Whether both obelisks truly went on the same hull, or whether the artist simply combined two journeys into a single image for the sake of the wall, is one of the oldest unresolved questions in the study of ancient Egyptian engineering. We will come back to it. For now, it is enough to say that even the most cautious reconstruction describes a wooden vessel larger than anything else known from the ancient world for a very long time afterwards, and that the boldest reconstruction describes something that would not be equaled until the great ships of the Renaissance. She was built without iron. She was built without a saw of steel, without a nail, without a keel in the sense that a later shipwright would understand the word. She was built by men who joined planks, edge to edge with wooden tenons, pegged through mortices, who lashed and pinned and trusted, who understood the behavior of timber under load the way a musician understands the tension of a string. And she was built quickly, if the inscriptions are to be believed, because the queen who commissioned her was in a hurry, and because in Egypt the river itself set the schedule. The flood came when it came. If you missed it, you waited a year. The name of the woman who ordered all of this was Hatshepsut. She ruled Egypt in the 18th dynasty, in the 15th century before the Common Era, in the long, bright afternoon of the New Kingdom, and she has been argued about ever since. She was the daughter of one king and the widow of another, and when her stepson was too young to rule alone, she took the throne, and then she simply kept it for something like 2 decades. She had herself carved as a king, with a king's ceremonial beard and a king's stride and a king's titles. She sent a great expedition down the Red Sea to the land of Punt and brought back incense trees with their root balls wrapped in matting. She built a terraced temple against the cliffs of the western desert that is still, 3,000 years later, one of the most quietly astonishing buildings anyone has ever raised. And she gave to the god Amun at Karnak a pair of obelisks, and then another pair, and she left, on the walls of her temple, the record of how the stone came down the river. This is a story about ambition, and about wood, and about water, and about the strange patience of people who set out to move something that should not have been movable. It is a story with a great deal of stone in it, and a great deal of rope, and a great many men whose names we will never know, pulling in rhythm on a river in the heat. If you find yourself drawn to stories like this one, to the great ships of history and the people who built them, you might consider subscribing to the channel so that the next one finds you when you need it. There is no hurry. Settle in, let your breathing slow, and let the river take us south, upstream, against the current, toward the granite. The world in which this ship was built was old even to the people who lived in it. Egypt in the 18th dynasty was not a young civilization discovering itself. It was an ancient one, conscious of its own antiquity, walking every day among monuments that had already stood for 1,000 years and more. When Hatshepsut's shipwrights laid out the timbers of the great barge, The pyramids at Giza were older to them than the fall of Rome is to us. The step pyramid of Djoser was more ancient still. Egyptian scribes copied texts whose language they found difficult and archaic. Priests maintained the cults of kings who had been dead for 50 generations. There was, running underneath everything, a deep assumption that the important things had been established long ago and that the duty of the present was to maintain them, restore them, and if one were fortunate and pious and well supplied with granite, to add to them. The country itself was a shape drawn by water. The Nile came out of the south, out of regions that no Egyptian had ever seen, and it ran north for a great distance between deserts, and every summer it rose. The rise was not violent in the way of a flash flood. It was a swelling, a slow lifting of the water over the fields, brown with the silt it had carried from far away, and it laid that silt down across the land in a thin, fertile film, and then withdrew. Everything the Egyptians had came from that. The grain came from it, and the beer and the bread came from the grain, and the wealth of the temples came from the bread, and the armies came from the wealth. The Egyptians measured their year by the flood. They had a season of inundation, a season of emergence when the land came back out of the water and the seed went in, and a season of harvest and heat and low water. The barge in this story could not be loaded at any moment its builders chose. It could only be loaded when the river was high enough to reach the place where the stone lay. And that is a fact that shapes the entire chronology of what follows. Along the river ran the towns, strung like beads on a cord. In the north, in the delta, the water broke into many branches and spread into marshland and the sea. In the south, above the ancient capital of Memphis, the valley narrowed and the cliffs came close on either side, and the strip of green was sometimes only a few kilometers wide, sometimes less, a green thread between two immensities of stone and sand. And near the southern end of the inhabited valley, where the river ran over hard rock and broke into rapids that boats could not easily pass, stood the frontier town of Elephantine, and near it the region we now call Aswan. Aswan mattered because of what lay under it. The bedrock there is granite, an igneous stone of enormous hardness, speckled pink and grey and black, capable of taking a polish like glass and of holding a carved line for millennia without blurring. There was granite elsewhere, but the granite of Aswan was the granite the kings wanted. It had gone into the sarcophagi of the pyramid builders. It had gone into the lining of burial chambers, into statues, into thresholds and door frames and shrines. And it went, above all, into obelisks, because an obelisk had to be cut from a single piece of stone. And there are not many places on Earth where you can take a single, flawless piece of stone 40 meters long out of the ground. The city that would receive the stone lay far to the north of the quarries, though still deep in the south of the country as the Egyptians reckoned it. Thebes had grown from a provincial town into the religious heart of the kingdom, and the reason for its rise was a god. Amun had once been a minor deity, obscure, a god whose name meant something like the hidden one. But the princes of Thebes had driven out the foreign rulers who had held the north, and had reunited the country, and had founded the dynasty to which Hatshepsut belonged. And as they rose, their god rose with them. By her time, Amun was merged with the old sun god of the north, and worshipped as Amun-Ra, and he was the greatest god in Egypt. And his house at Karnak on the east bank of the river was becoming the largest religious complex the world had yet seen. It grew by accretion, king after king, adding a pylon, a court, a hall, a shrine, an avenue of sphinxes, a pair of obelisks. It was never finished. It was not meant to be finished. It was meant to be added to. And every ruler who added to it was making a statement not only about piety, but about power, because the stone said, without needing words, that the person who put it there could command the labor of a nation. Across the river, On the west bank was the land of the dead, and behind the cultivated fields, the cliffs rose in a great bay of pale rock. And in that bay, Hatshepsut built her temple. It stands there still, terraced, colonnaded, set against the cliff so precisely that it looks as though the cliff had been made for it. On the walls of the middle terrace, in the colonnade, her craftsmen carved two great narratives. One was the expedition to Punt, that distant land somewhere to the south along the Red Sea coast, from which came incense and ebony and ivory and living myrrh trees. The other was the transport of the Obelisks. Both were, in their way, stories about ships. Both were stories about reaching out from Egypt and bringing back something extraordinary and setting it before the god. Hatshepsut's route to the throne was not the ordinary one, and everything she built has to be read with that in mind. She was the daughter of Thutmose I, a soldier king who had pushed Egypt's borders far to the south and to the north. She married her half-brother, who ruled briefly as Thutmose II, and then died young. The heir was a boy, the son of her husband by another woman, and that boy became Thutmose III while still a child. Hatshepsut began as regent, which was an accepted and unremarkable role for a royal woman. But within a few years, she was no longer merely regent. She took the full titulary of a king. She was depicted in the regalia of a king. She adopted a throne name, and in the formal language of monuments, she was addressed with the words used for a male ruler. And in the same texts, she was sometimes described in feminine terms as well, so that the record blends and shifts in ways that scholars still find fascinating. There is a temptation to make a melodrama of this, and it is a temptation worth resisting, because the melodrama is mostly modern. We do not know how it felt inside the palace. We do not have a single letter in which anyone complains. What we have is stone, and the stone tells us that for roughly 20 years, Egypt was prosperous, that trade expeditions went out and came back, that quarries were worked and temples were built, and that the young Thutmose III grew up, learned to command an army, and eventually became one of the most effective military kings in Egyptian history. Whatever the arrangement was, it held. But a ruler in Hatshepsut's position needed something more than a quiet reign. She needed legitimacy, and legitimacy in Egypt was expressed through the gods. So she told on her temple walls the story of her divine birth, in which Amun himself was said to have taken the form of her father and fathered her, so that she was not merely a king's daughter, but a god's daughter. And she gave to Amun gifts of a scale that no one could ignore. The obelisks were part of that. They were not decoration. They were argument, made in the hardest material available, addressed to the god and to the priesthood and to the people and to the future. And behind the argument stood the practical problem, which was that the stone was in the south and the god was in the north. And between them lay 200 kilometers and more of river, and no one had ever moved anything so heavy so far. To understand why anyone would go to such lengths, it helps to understand what an obelisk actually was, in the minds of the people who raised them, because to us they are simply tall stones, and to them they were something considerably stranger and more urgent. The word we use, obelisk, is not Egyptian. It comes from Greek, and it means, more or less, a little spit or skewer, which is a rather comic diminutive for an object weighing hundreds of tons. And it tells us something about how the Greeks reacted when they first saw them. The Egyptian word was different. They called such a stone a tekun, and what a tekun was, in the religious imagination, was a ray of the sun made solid, a shaft of light that had been petrified and set upright in the world so that it could stand there permanently, joining the earth to the sky. The sun was the central fact of Egyptian religion, as it was the central fact of Egyptian agriculture and of Egyptian daily life. The sun rose, crossed the sky, sank into the west, passed through the underworld during the night, and rose again. And this journey was the fundamental rhythm of existence, the guarantee that order would keep defeating chaos, that tomorrow would come. At the ancient sun temple at Heliopolis in the north, there was said to be a sacred stone called the benben, a squat conical or pyramidal object which represented the first mound of land to emerge from the waters of chaos at the beginning of creation, and which was also the place where the first light fell. The tip of an obelisk was a benben in miniature, a pyramidion, and it was often sheathed in gold or in electrum, that pale, bright alloy of gold and silver that the Egyptians prized. Set on top of a shaft nearly 30 meters tall and standing in the open air before a temple, the gilded tip would catch the sunrise before anything else in the city. The light would touch it first. In a very literal sense, the obelisk was designed to be the first thing the sun spoke to each morning. They were raised in pairs, flanking the entrance to a temple, one on each side of the gate, and the pairing mattered. Egyptian thought was full of paired things, of balances and complements, of two lands and two crowns, and two banks of the river, and a single obelisk would have been an unfinished sentence. So they were quarried in pairs, transported in pairs, and set up in pairs, and inscribed with vertical columns of hieroglyphs running down each of the four faces, naming the king who gave them and the god who received them, and describing the gift in the formal, resonant language of royal inscription. Hatshepsut raised more than one pair. The first pair went up early in her reign, at Karnak, and of those the fragments are scant. The second pair is the one that concerns us, the pair whose transport is carved on the walls at Deir el-Bahri, and of that pair one still stands, in the great hall between two pylons at Karnak, and the other lies broken beside the sacred lake. And on the base of the standing one there is an inscription, and in that inscription there is a claim so extraordinary that people have been arguing about it ever since it was read. The inscription says, in effect, that the work took 7 months from the quarry to the moment the stones stood upright at Karnak. 7 months. From the first blow of the pounding stone at Aswan, through the cutting of a shaft of granite nearly 30 meters long, through its detachment from the bedrock, its removal from the quarry, its journey overland to the water, its loading onto a vessel, its voyage of some 200 kilometers downriver, its unloading, its transport to the temple, and its erection upright on a base without any of it cracking, and all of this twice over, because there were 2 of them. 7 months. There are 2 ways to receive a claim like that. One is to take it as a straightforward statement of fact, in which case the achievement is close to miraculous and the organization behind it must have been staggering. The other is to remember that this is a royal inscription, that royal inscriptions in Egypt are not neutral reports, but public assertions of the king's power and the god's favor, and that the 7 months may refer to only part of the process, or may be a formal figure meant to convey extraordinary speed rather than to be checked against a calendar. Egyptologists are divided, and the honest position is that we do not know. What we can say is that the Egyptians themselves regarded the speed of the work as one of the most impressive things about it and chose to record it, which tells us that they understood perfectly well how difficult it was and wanted the reader to understand that too. The inscription also says other things worth pausing on. It speaks of the queen's devotion to her father Amun and of her wish that the obelisks should be worthy of him. It speaks of the tips being covered with the finest electrum, measured out in great quantity, as one measures sacks of grain, which is the kind of detail that reads as a boast, and probably was one. And in one passage, in a tone that is rare in Egyptian royal texts, it addresses the future directly, and asks that those who come afterwards should not say that the queen did not know what she was doing, or that she spoke idly, but should understand that the work was real and that she paid for it. That is a curious note to strike, and it is difficult not to hear a certain defensiveness in it, a woman on a throne that women did not usually occupy, insisting that her monument be judged on its own terms. It may be overreading. Egyptian inscriptions often address posterity, but it lingers. There was also a practical, political occasion. Egyptian kings celebrated a Jubilee festival, a renewal of kingship traditionally marked after a long reign, and a great gift to the god was an appropriate way to mark such a moment. Hatshepsut's obelisks appear to have been connected with such a festival, though the precise sequence of events is not perfectly clear from the surviving evidence. What matters is the pattern. A ruler who needed to demonstrate that the gods approved of her reign made the largest and most visible offering that Egyptian religion allowed, and made it out of the hardest and most permanent material available, and set it where every priest and every pilgrim and every foreign envoy who entered the house of Amun would have to walk between the two of them and look up. Stone is a slow argument, but it is a very persistent one, and so the order went out, south, to the granite. Somewhere in the administration of the queen, there was a man whose responsibility it became to make this happen, and his name has survived, which is more than can be said for most of the people in this story. He was called Senenmut, and he is one of the most intriguing figures of the 18th dynasty. He rose from a family of no great distinction. He accumulated titles in remarkable numbers, dozens of them, overseer of this and steward of that, and he was tutor to the queen's daughter, and he had a hand in the great building works of the reign, and he was permitted the extraordinary privilege of having his own image carved in small hidden niches within the queen's own temple. In one of his inscriptions, he says that he conducted the work of the two great obelisks. Later ages have speculated endlessly about his relationship with the queen, and the speculation has produced a great deal of fiction and very little evidence, and we will leave it there. What is certain is that a person of high authority was given charge of an engineering project of unprecedented scale, and that the project was carried out. The granite waited in the south. It had waited a very long time already. The granite of Aswan is not a stone that yields. It was formed deep in the earth under enormous pressure, cooled slowly, and its crystals interlock in a way that gives it a strength and a hardness far beyond that of limestone or sandstone. You cannot cut it with a copper chisel. Copper was the metal the Egyptians had in quantity, and copper is soft, and a copper edge brought against granite will blunt itself in a few strokes and achieve nothing. Bronze is harder, and bronze was known, but bronze against granite is still, for practical purposes, a losing contest. Iron was not yet in common use, and even if it had been, the working of granite is not primarily a problem of cutting. It is a problem of patience. What the quarrymen used instead was granite's own family. They used dolerite, a dark, igneous rock, tougher than the granite itself, and they used it not as a blade, but as a hammer. Rounded lumps of dolerite, some of them weighing several kilograms, have been found in the quarries in quantity, worn and battered from use. A man would take one of these in both hands and bring it down on the surface of the granite, and the impact would shatter away a small quantity of the stone in a fine dust and a scatter of chips. Then he would do it again, and again. The rock did not so much yield as slowly erode under a rain of blows, and the sound of it, hundreds of men at once, in an open quarry under the southern sun, must have been continuous and strange, a kind of dry, hammering roar that carried across the water. Nothing about this was fast. Modern experiments, in which people have attempted to reproduce the technique with authentic materials, suggest that a skilled worker pounding steadily might remove a few centimeters of granite in an hour over a small area, which sounds impressive until you consider the volume of stone that had to be removed to free an obelisk. To extract a shaft of that size, the quarrymen did not cut it out of a cliff face. They worked downward and around, sinking a trench in the living bedrock along the entire outline of the intended obelisk, deep enough to expose its full thickness so that when they were finished, the obelisk lay there in its bed like a fish in a mold, attached to the earth only along its underside. The trench had to be wide enough for a man to stand in and swing a pounder. It had to run the whole length of the shaft, down one side, around the tip, back up the other side, and across the butt. And every centimetre of that trench was made by men hitting rock with other rock. We know exactly what this looked like, because there is an obelisk still lying in the quarry at Aswan, and it was never finished. It is called, simply, the unfinished obelisk, and it is one of the most eloquent objects to survive from the ancient world, because it is a project caught in the act of failing. It lies in its trench, on its back, its outline fully defined along three sides, its surface still bearing the shallow, scalloped hollows left by the pounding stones, so regular that you can see where individual workers stood. It is enormous. Had it been completed and raised, it would have stood something in the region of 42 meters, which is to say half again as tall as the great obelisk Hatshepsut actually erected, and its weight has been estimated at more than 1,000 tons. It would have been, by a wide margin, the largest obelisk ever made. And it cracked. Somewhere in the course of the work, a fissure opened in the granite, running through the body of the shaft, and the stone was ruined. Granite is not homogeneous. It has flaws, seams of weakness, inclusions, and there is no way to see them from the surface. The quarrymen had committed months of labor and an unknown quantity of food and water and organization to a piece of rock that turned out to have a fault in it. And when the fault revealed itself, the work stopped, and the tools were set down, and everyone walked away, and the obelisk stayed where it was for 3,500 years. Whether it was Hatshepsut's is not certain. It is often attributed to her, and the attribution is plausible on grounds of date and ambition, and some scholars have suggested it may have been intended as a single colossal monument rather than one of a pair. Others place it later, or leave the question open. It is one of the many places in this story where the honest answer is that we do not know. But whoever ordered it, its lesson is the same, and the men who worked on Hatshepsut's obelisks would have understood that lesson very well. The stone decides. You can organize the labor and provision the camp, and choose the site with all the skill your experience gives you, and the rock can still betray you at any moment, and there is no appeal. So they worked carefully. The choice of site would have been made by men who knew the quarry intimately, who could read the surface of the rock, who understood the way the granite in that particular place tended to split. They would have cleared the weathered upper layer, the crust of stone softened and stained by millennia of exposure, to get down to sound material. They would have laid out the shape of the obelisk on the surface, its length, its taper, the slight narrowing from butt to tip that gives an obelisk its particular elegance, and which is not a simple straight taper at all, but a subtle curve. And then the pounding began, and it went on for months. There is an old story, repeated in many popular accounts, that the Egyptians split granite by driving dry wooden wedges into slots cut in the rock and then soaking them with water so that the swelling of the wood cracked the stone. It is a satisfying story, and it may be true of some periods and some materials, but for the granite of the Old and New Kingdoms, the evidence for it is thin, and many specialists now doubt it. The wedge slots that survive in Egyptian quarries mostly belong to much later periods, Roman and after. What survives from the age of the obelisks is pounding, and pounding is not a trick. It is simply work. Around the quarry there would have been a camp, and around the camp a supply line. The men had to eat, and in the south, in that heat, they had to drink. and every loaf of bread and jar of beer and bundle of onions had to be brought in from somewhere and distributed and accounted for. Egyptian administration was, by the standards of the ancient world, formidable. Scribes counted things. They counted them obsessively, on papyrus and on shards of pottery and flakes of limestone, and the survival of such records elsewhere gives us a sense of how a project like this would have been run. There would have been overseers and gangs organized into named crews, and rations issued, and days recorded, and absences noted, and a great deal of routine bureaucratic effort of a kind that never appears on temple walls because it is not glorious, and without which nothing would ever have been achieved. We should also say something about who these men were, because there is a persistent modern assumption that the great works of Egypt were built by slaves under the whip, and the evidence does not support it in the form the assumption takes. The workers on royal projects appear to have been, for the most part, Egyptians performing labor service, conscripted for a season, organized into gangs, fed and housed, and eventually sent home. Skilled quarrymen and stoneworkers were craftsmen with status. There were certainly captives and forced laborers in Egypt, and there was certainly compulsion in the system. And it would be sentimental to pretend that the men swinging dolerite pounders in the summer heat were volunteers. But the picture of a nation of slaves driven by cruelty is a later invention. And the truth is both more ordinary and, in its way, more impressive. A state capable of mobilizing thousands of ordinary people, feeding them, organizing them, and directing their effort at a single object, year after year, for reasons they mostly seem to have accepted. Slowly the trench went down. Slowly the shape emerged from the bedrock, its edges defined, its faces roughed out. And at some point, the pounding along the sides stopped, and the far harder task began, which was to separate the obelisk from the earth beneath it. This was the moment of greatest danger. Up to now, the stone had been supported along its entire underside by the rock it was born from. To move it, that support had to be removed, and the moment it was removed, the obelisk became what it would remain for the rest of its journey. A long, slender beam of brittle material, hundreds of tons in weight, that would break if it were ever unevenly supported. Exactly how they did it is not fully known, and this is the point at which reconstruction becomes argument. The likeliest approach, and the one favored by most of those who have studied the quarries, involved undercutting the shaft progressively from both sides, working in beneath it, and packing the space that opened up with supports as they went, so that the stone was never left hanging over a void. Wooden beams, stone blocks, packed sand, all have been proposed. Levers of hard wood, worked in patient inches with many men on each, would have been used to lift and shift. Sand is a particularly interesting possibility, because sand is a material the Egyptians understood profoundly. It can be piled, and it can be dug away, and if you fill a space with sand and then let the sand out slowly through an opening, whatever rests on the sand will descend slowly and evenly. And that is a way of lowering an immense weight in a controlled manner without ever letting it fall. Whatever the precise method, the obelisk had at some point to be lifted clear of its bed and got onto a sledge. And here we can be more confident, because sledges are shown in Egyptian art repeatedly and unmistakably. A sledge was a heavy wooden frame with two long runners, and it was the standard means by which the Egyptians moved massive objects overland. There were no wheels. Wheels existed in Egypt by this period, on chariots, but a wheel is a poor solution for hundreds of tons on soft ground because it concentrates the load and sinks. A broad runner spreads the load, and the runners were made to slide by pouring water, or possibly a mixture of water and finer material, onto the ground ahead of them, which reduces friction dramatically. There is a famous scene from a slightly different context, showing a colossal statue on a sledge, dragged by rows of men. and standing on the front of the sledge is a figure pouring liquid from a jar onto the ground in front of the runners. And for a long time, people assumed he was performing a ritual, and it now seems very likely that he was performing physics. The route from the quarry to the water was not long, perhaps a kilometer or so, but every meter of it had to be prepared. The ground had to be leveled and packed, obstacles cleared, a causeway built where the land dipped. The obelisk on its sledge had to be pulled by ropes, and the ropes were made of palm fiber or halfa grass, and there had to be a great many of them, because no single rope of ancient manufacture could take that load. Men would have hauled in ranks, hundreds of them, with overseers calling the rhythm, and the movement would have been achieved in short pulls, a meter at a time, with rests between, and the whole business of getting one obelisk from the quarry to the riverbank may well have taken weeks. And at the end of that haul, at the water's edge, there was a ship waiting, or there was a place where a ship would be. And that ship had to be built first. We do not know where the great barge was built, and we do not know who designed her. The Egyptian record, so generous with the names of officials, and so lavish with the titles of kings, is silent on the identity of the master shipwright who worked out how to make a wooden hull carry the weight of a small hill. He existed. Someone stood in a boatyard with a plan in his head and made decisions about scantlings and joints and the run of the planking, and was answerable for those decisions in a way that few men have ever been answerable. Because if he was wrong, the Queen's obelisks would go to the bottom of the Nile, and the Queen would want to know why. Egyptian shipbuilding was ancient and highly developed, and it had grown up around a particular and rather unpromising material problem. Egypt has almost no good shipbuilding timber. The trees that grow along the Nile are acacia and sycamore fig and tamarisk and date palm, and none of them is ideal. Acacia is hard and durable and rot-resistant, but it grows crooked and does not yield long, straight planks. Sycamore is workable but soft. Palm is fibrous and structurally poor. The consequence is that Egyptian boats, from the earliest periods, were built out of short pieces, where a Mediterranean or northern shipwright might take a single long plank and run it most of the length of the hull. The Egyptian shipwright had to assemble his planking out of many small, irregular pieces, fitted together like a jigsaw and joined edge to edge. The method they developed for this is one of the quiet triumphs of ancient technology. The planks were shaped so that their edges met, and into the mating faces the shipwrights cut mortices, rectangular slots, and into those slots they drove tenons, flat tongues of hardwood, so that each plank was locked to its neighbor by a row of hidden wooden keys. In many cases, the tenons were pegged in place with dowels driven from the face of the plank, and in some hulls, particularly the earlier ones, the planks were additionally lashed together with rope, passed through channels cut in their inner faces. The result was a shell, a skin of joined timber, structurally continuous, built up plank by plank, and only afterwards stiffened from within by frames and beams. This is the opposite of the way most later ships were built, where a skeleton is erected first and then planked over. The Egyptian hull was a shell first, and the internal structure was an afterthought in the literal sense. It came after. We know this in detail, and not merely from pictures, because one Egyptian ship survives almost entire. In the year 1954, an archaeologist named Kamal el-Malak, working at the foot of the Great Pyramid at Giza, found a sealed pit beneath the limestone paving, and in the pit, packed in careful order, were more than 1,000 pieces of cedar. They were the disassembled parts of a ship, buried beside the Pyramid of Khufu more than 4,500 years ago, sealed away from air and moisture, preserved as if the carpenter had walked out that morning. It took years to lift them, and years more to put them together. And when the work was done, there stood a vessel more than 40 meters long, elegant, sheer-sided, curved up at bow and stern in the shape of a papyrus stem, held together by mortise and tenon and by ropes threaded through her planking, and with no keel at all. Nothing about her was crude. Everything about her showed a tradition that already, at that early date, knew exactly what it was doing. That ship was 1,000 years old before Hatshepsut was born. The tradition that built the great barge was therefore not new. It was mature, deeply experienced, and accustomed to working around the limitations of its timber. But the barge was not a river yacht for a dead king. She was a heavy cargo vessel of unprecedented size, and she would have to be built from better material than acacia. That meant cedar, and cedar meant the coast. The mountains behind the ports of the Levantine coast, in the region of what is now Lebanon, grew a cedar of extraordinary quality. Tall, straight, fragrant, resistant to rot and insects, and yielding timbers of a length that Egypt could not produce for itself. The Egyptians had been importing it for a very long time in exchange for gold and grain and manufactured goods, and there are records of cedar shipments going back to the Old Kingdom. It came down to the coast, and it was loaded onto seagoing ships, and it was brought to the delta, and from there it went up the river. For a project of this magnitude, the order for timber would have been substantial, and it would have gone out well in advance, because a tree in a mountain forest is a long way from a plank in a boatyard, and the delay between the two is measured in seasons. And even with cedar, the fundamental Egyptian technique did not change. The planks were still joined edge to edge with tenons. The hull was still a shell. Cedar simply allowed the pieces to be larger and the structure to be stronger. And for a vessel that had to bear a load like this one, the difference between acacia and cedar may have been the difference between a barge and a disaster. The problem the shipwright faced can be stated in a single sentence, and it is a sentence that has kept naval architects awake for a century. A long ship carrying a heavy concentrated load in the middle wants to bend. The buoyancy of the water pushes up along the whole length of the hull, but the weight is not distributed along the whole length, and the difference between where the support is and where the load is generates enormous bending moments. In the worst case, the ends of the ship are lifted by buoyancy, while the middle is pressed down by the load, or the reverse, and the hull cracks somewhere amidships and the ship folds like a wet leaf. Modern ships resist this with steel girders running the length of the hull, with longitudinal framing and stringers and a keel that acts as a spine. The Egyptian barge had none of these things. What it had, if the pictures are to be believed, was a truss. Look at almost any depiction of a large Egyptian ship, including the barge at Deir el-Bahri, and you will see a heavy cable running from the bow, up over a series of forked posts or crutches, standing along the centerline, and down to the stern, held clear of the deck. This is what is usually called a hogging truss, and its purpose is exactly what its name suggests. Hogging is the condition in which the ends of a hull droop and the middle rises. The cable, tensioned by twisting it with a bar, pulls the two ends of the ship up and inward, opposing the sag, and it can be tightened as required. It is, in effect, a rope substitute for a keel, and it turns the ship into a kind of bow, strung and under tension. Whether a hogging truss alone would have been sufficient for a hull carrying several hundred tons of granite is precisely the question that reconstructions disagree about. Some have argued that the barge must also have had a very heavy internal structure, massive longitudinal timbers laid within the hull, a great built-up girder along the centerline, deck beams of enormous section running from side to side and locked into the planking. Others have argued that the extraordinary breadth of the vessel is itself the answer, that a hull so wide behaves quite differently from a narrow one, and that the load, if spread over a sufficiently large area of bottom, need not have produced the concentrations of stress that a narrower ship would have suffered. The Egyptians did not have engineering theory in the modern sense. They had no equations for bending stress. What they had was accumulated craft knowledge, generations of it, an intuition for timber refined by centuries of practice. And they had the willingness to make things very much heavier and thicker than a modern designer would, because they had no way of calculating exactly how thick was thick enough. And the cost of being wrong was catastrophic. So they built her, in a yard somewhere on the riverbank, over months, out of imported cedar and native acacia. Plank by plank, tenon by tenon, with copper and bronze tools, and adzes and bow drills, and mallets, and a great deal of accumulated confidence. And she rose above the mud, wide and flat and low, unlike anything else on the river, and the men who worked on her would have known perfectly well that they were building something no one had built before. It is worth lingering in that yard a little longer, because it is one of the few places in this story where we can imagine the work with some confidence, and because the smell of it would have been extraordinary. Cedar, freshly cut, is intensely aromatic. It has a resinous, sweet, slightly bitter scent that clings to the hands and to the clothing, and a yard full of cedar shavings in the heat of an Egyptian afternoon would have smelled like nothing else in the country. Mixed with it, there would have been the smell of the river, which is silt and reeds and warm mud, and the smell of pitch or resin if the seams were being paid, and the smell of rope, which is dry and grassy and faintly dusty, and the smell of a great many men working hard in the sun. The sounds would have been layered too, and mostly percussive. The adze was the primary shaping tool of the Egyptian carpenter, a blade set at right angles to a wooden haft, swung toward the worker's own feet, taking off a curl of wood with each stroke, and a yard full of men adzing planks makes a rhythm like rain on a roof. There would have been the tap of mallets driving tenons home. There would have been the peculiar whirring of the bow drill, a stick spun back and forth by a bowstring wrapped around it, used to bore the holes for the dowels, and a man could work one all day. There would have been the rasp of sandstone rubbers smoothing a surface, and the sawing of the pull saw, which cuts on the draw stroke rather than the push, and the constant low noise of instruction and argument and counting. Egyptian woodworking tools survive in some numbers, and they are recognizable to any carpenter alive today. The adze, the chisel, the mallet, the saw, the drill, the square, the plumb line, the marking string dipped in pigment and snapped against the timber to leave a straight line. There is a set of tools from this general era that could be laid out on a bench in a modern workshop, and every item in it would be identified correctly by anyone with a trade. What is missing is the plane, which the Egyptians appear not to have had, and the metal fastening, which they did not use in hulls, and the frame saw large enough to convert a great log into planks in the manner of a later sawmill. They cut their planks with hand saws and with wedges and with patience, and the conversion of imported cedar logs into usable timber was itself a large operation requiring skilled men. And all of that timber had come a very long way, and its journey is a story in itself. The cedar grew on mountain slopes several hundred kilometers from Egypt, in a region reached by sea, and the trade in it was old and formal and conducted through the ports of the Levantine coast, of which the most famous was Byblos. Byblos and Egypt had a relationship going back many centuries, an exchange of goods and of religious ideas so deep that a Levantine goddess was worshipped in Egyptian terms, and Egyptian objects turn up in the temples of the coast. The Egyptians sent gold and grain and linen and finished goods, and the ships came back low in the water with logs. Getting the timber out of the mountains was hard. The trees had to be felled with axes on slopes and then moved down to the coast, and the descriptions we have from other periods speak of dragging and of oxen and of a great deal of labor. Then the logs were loaded onto seagoing ships, and there are Egyptian reliefs showing exactly this. vessels with high sides and heavy rigging putting to sea with cargo aboard, and men in the rigging, and the Egyptians did not much like the sea and said so, and made the voyage anyway because the wood was necessary. The timber arrived in the delta at a port and was transferred to rivercraft and went south, upstream, under sail, because the wind on the Nile blows conveniently from the north almost all the year, and a ship going upriver could simply raise a sail and let the wind push her against the current. That is the great gift of Egyptian geography, and it is why the hieroglyph for traveling south is a boat with a sail set, and the hieroglyph for traveling north is a boat with the sail furled and the oars out. Everything in the country moved on that principle, and the cedar for the barge moved on it too, hundreds of kilometers from the sea to the yard before a single plank was cut. So the barge, before she was anything, was a supply chain. She was a decision taken years in advance, an order placed, a forest cut on a foreign mountain, a sea voyage, a river voyage, a stockpile of timber lying in a yard under matting to keep the sun off it, and only then, at last, a ship. If we could stand in that yard and walk the length of her, what would we see? The honest answer is that we would see whatever the reconstruction we happen to believe tells us to see, because the barge exists for us only as a drawing on a wall, and the drawing was made by an artist working within a strict set of conventions that were never intended to serve a naval architect 3,000 years later. Egyptian relief carving does not attempt perspective. It shows things in their most characteristic aspect, which is to say, a ship is shown in profile because a ship is most recognizable in profile, and a fleet of boats is shown in stacked rows because that is how you fit 30 boats onto a wall, not because they were sailing on top of one another. Proportions are adjusted for clarity and for importance. Figures of the king are larger than figures of servants, not because the king was a giant, but because he mattered more. This is not primitive drawing. It is a different and entirely coherent system, and it conveys the information the Egyptians wanted, conveyed with great efficiency. What it does not do is give us measurements, and yet measurements are exactly what people have tried to extract from it, ever since the temple at Deir el-Bahri was cleared and recorded, and the effort has produced a debate that is now well over a century old. The relief shows a barge, seen from the side, long and low, her bow and stern curving upward and inward in the papyriform manner, terminating in ornamental finials. Along her deck lie two obelisks, arranged end to end, tip to butt, with their pyramidions shown clearly. The hull is drawn with a heavy hogging truss above the deck, supported on posts. At the stern is a great steering arrangement, a cluster of enormous rudder oars, rather more of them than any ordinary vessel would carry, mounted on posts and manned by helmsmen. Ahead of the barge, in ranks, are the towing boats, each with its own crew of rowers, each with its tow rope, and among them boats that seem to have other functions, perhaps guiding, perhaps carrying priests and offerings, perhaps setting the stroke. From that image, and from the known dimensions and weight of the standing obelisk, the reconstructors have gone to work. The first serious attempt in the modern era belongs to a man named Reginald Engelbach, an English engineer turned Egyptologist, who was for some years Chief Inspector of Antiquities at Aswan, and who published, in the 1920s, a book called The Problem of the Obelisks. It is a remarkable piece of work, because Engelbach came at the question not as a philologist, but as someone who had actually to think about weights and forces and what could be done with rope. He studied the unfinished obelisk in the quarry. He measured, he reasoned, and he proposed methods for extraction, transport, and erection that are still the starting point for every discussion of the subject. His barge was large. Working from the assumption that both obelisks traveled together on a single hull, he arrived at a vessel of very great length and a beam of perhaps 30 meters or more, and a total displacement loaded of a magnitude that startled his readers. Others have argued for something smaller. The Swedish maritime historian and illustrator Björn Landström, who spent much of his life reconstructing ancient vessels and whose drawings of Egyptian ships are still widely reproduced, proposed a barge in the region of 63 meters in length and around 21 in beam. That is still a very large ship by any ancient standard, larger than most warships that would be built in the Mediterranean for another 1,000 years. But it is not the floating platform of Engelbach's imagination. The disagreement is not merely aesthetic. It turns on a genuine question about the evidence, and the question is this: did the two obelisks really travel together? The relief shows them together. But the relief also, elsewhere on the same wall, compresses a whole expedition to a distant land into a handful of ships and shows events separated in time as if they were simultaneous. Egyptian art regularly does this. It is a language of summary, not of reportage. It is entirely possible that the artist showed both obelisks on one barge because the inscription and the gift concerned a pair, and a pair is what had to be shown, and that in reality the barge made the journey twice, carrying one obelisk each time. If she carried one, the engineering problem is halved, and the hull required is very much more modest, and everything becomes considerably easier to believe. If she carried both, then we are looking at a wooden vessel with a cargo of 600 or 700 tons of granite, and a total weight afloat approaching or exceeding 1,000 tons. And that is a ship whose like would not be seen again on any water for a very long time indeed. There is no way to settle this from the relief alone, and no wreck has ever been found. The river bottom of the Nile is not kind to archaeology. It is a system of moving silt, and it has been shifting and depositing for millennia, and any ship that sank in it is now, in all likelihood, buried meters deep under mud in a place where the channel no longer runs. It is not impossible that something will one day be found. It has not been found yet. So we are left with a set of arguments, and the arguments are worth listening to. Those who favor the single large barge point out that the Egyptians had every reason to want to do the job once rather than twice, that the flood season gave them a limited window, that the barge would have had to be built regardless, and the cost of building it very large was not proportionally greater than the cost of building it merely large, and that the relief, whatever its conventions, is the only direct evidence we have, and it plainly shows two obelisks on one hull. Those who favor two voyages, or two barges, point out that the risk of putting both obelisks on one vessel is enormous, that a single accident would have destroyed years of work and both monuments together, and that a prudent administration would not have gambled that way. They point out that the hull required for the double load is at the very outer edge of what wooden construction without iron fastenings can plausibly achieve. And they point out that the relief is not a photograph. Both positions are held by serious people, and the disagreement has been civil and productive, and it has produced a great deal of careful thinking about the properties of wood. There have also been more radical proposals. One suggestion, developed in some detail, is that the obelisk was never lifted onto a deck at all, but was slung between two vessels, or carried beneath a raft, or supported by paired hulls in the manner of a catamaran, so that the buoyancy could be arranged around the load rather than under it. Another is that the transport used pontoons, sealed empty vessels lashed together, rather than a single ship in the ordinary sense. None of these has commanded general agreement, and each has to explain why the relief shows what it shows. But they are useful because they remind us that our instinct to imagine a single conventional hull may itself be an assumption we have imported from a later maritime world. What everyone agrees on is that whatever floated under those obelisks was extraordinary, and that it required an understanding of buoyancy and of load distribution that the Egyptians had acquired without any of the mathematics we would use, and that they got it right because the obelisks arrived. There is one more feature of the relief worth dwelling on, and it is the steering. At the stern of the barge, the artist shows a great array of steering oars, sometimes counted as 4 on each quarter, mounted on stout posts and worked by a considerable number of helmsmen. This is not decoration. A vessel of that size and that draft, moving in a river current with no engine and no rudder in the later sense, would have been almost unsteerable by ordinary means. She had to be kept in the channel, kept off the banks, kept from swinging broadside to the current, and she had to answer, sluggishly but reliably, to the men at the stern. The multiplication of steering oars tells us that the Egyptians knew this and had thought about it and had solved it by brute redundancy. If one oar cannot turn her, use 8 and put a man or 2 on each and have a pilot who knows the river. Which brings us to the question of how the stone got aboard, and that is the hardest question of all. Consider the problem plainly. You have an obelisk lying on a sledge on the bank. It weighs something in the order of 300 tons. You have a barge floating in the river. You must transfer the one onto the other without breaking the obelisk, without capsizing the barge, and without any crane, any winch capable of such a load, or any hydraulic equipment whatsoever. The obelisk cannot be lifted. Nothing in the ancient world could lift it. It can only be slid, or lowered, or floated. The solution that most reconstructions favor is elegant, and it depends entirely on the annual behavior of the river. And it goes something like this. Before the flood comes, while the water is still low, you dig a canal or a trench inland from the river, at right angles to the bank, and you dig it deep, deeper than the draft of your loaded vessel. You line it, perhaps, or you shore its sides. At the landward end, you build up a solid platform or ramp, level with the ground, at exactly the height at which the deck of your barge will sit when she is floating and loaded. Then you bring the barge into the canal, and you sink her, or you let the water out, or you allow her to settle onto the bottom of the trench so that her deck lies at the level of the ground, and the obelisk on its sledge can be dragged directly onto her, horizontally, without any lifting at all. And then you flood the canal. The water comes in, or the river rises, and the barge, with all that granite aboard, floats. She does not have to lift the obelisk. The river lifts her, and the obelisk with her, and the whole burden rises as gently as bread. Then the canal is opened to the Nile, and she is towed out into the stream, and the load has been embarked without a single crane. That, at least, is the reconstruction, and it is attractive because it uses precisely the resources the Egyptians had in abundance: manpower for digging, timber for shoring, and above all, the reliable and predictable rise of the river. The flood is not an accident in this story. The flood is the machine. There are difficulties with it, and honesty requires that they be stated. Sinking a wooden ship deliberately and then refloating her is not trivial. A vessel that has been settled on a hard bottom under a heavy load may not lift cleanly. Silt gets in. Timbers strain. If the canal bottom is uneven, the hull is stressed in ways it was never designed for. And the barge, once she floats with the obelisk on board, must float level, because if she lists, the load will shift and the story ends very badly. The trim of that vessel, the placement of the obelisk fore and aft, the ballasting, all of it would have to have been calculated with a precision that we have no evidence the Egyptians could achieve on paper, and which they must therefore have achieved by experience, by trial, and quite possibly by having done something similar before on a smaller scale. That is a point worth holding on to. Hatshepsut's obelisks were not the first heavy stones ever moved by river in Egypt. Colossal statues had been moved. Granite sarcophagi had been moved. The pyramid builders, 1,000 years earlier, had brought granite from Aswan to Giza, a far longer voyage, and the blocks in the burial chamber of the Great Pyramid weigh many tons each, and some are very much heavier than that. The barge in this story stands at the end of a long tradition of moving impossible things on water. It is the largest expression of that tradition that we know of, but it is not an isolated miracle, it is a culmination. And so, at some point, in some season, in a trench cut into the bank of the river near Aswan, the water came up, and a great deal of cedar and acacia strained and creaked and lifted, and several hundred tons of granite rose off the ground and began, very slowly, to move. There is no sound in the relief, of course. Stone is silent. But we can reason about what the journey would have sounded like, because we know how the boats were propelled and how many men were involved. And the answer is that it would have sounded like an army. The barge could not sail. She had no mast that we can see. And even if she had, a hull of that beam and that draft, laden with granite, would have been almost impossible to manage under sail in the confines of a river channel. Nor could she be rowed. She was far too heavy for oars mounted in her own sides to have any useful effect. She had to be towed, and towing was done by boats. The relief shows the towing fleet, and the counting of it is one of the small pleasures of the wall. The boats are drawn in ranks, and the ranks are stacked one above another in the Egyptian manner. And if you take the stacking as a convention for lateral arrangement, as most scholars do, you arrive at a formation of something in the region of 27 boats, commonly reconstructed as 3 columns of 9, each column pulling on a common tow line, with additional vessels leading the whole procession. Each towing boat carries its own crew of rowers, and when the rowers are counted and multiplied, the total number of men pulling at the oars comes out in the region of 850 or more. The precise figures are debated, because the relief is damaged in places, and because the conventions of the drawing leave room for interpretation. And a careful writer will say only that the towing fleet was large and the number of oarsmen was in the high hundreds. But even the most conservative reading gives us a picture of astonishing coordination. 800 men in 27 boats pulling in time on a river with 1,000 tons of ship and stone behind them. Anyone who has ever rowed in a crew of 8 knows how difficult it is to get 8 people to pull together. The rhythm must be shared. If one man is early and another late, the effort is wasted and the boat checks. Now imagine that problem multiplied 100-fold, spread across a fleet, with the boats at the back unable to see the boats at the front, with the noise of the water and the wind and the creaking of ropes, and with an object behind you so heavy that if the pull is uneven, the tow lines will snap or the barge will yaw across the current. They solved it, as far as we can tell, with sound. Egyptian rowing scenes frequently show a man setting the time, and the setting of time in a large fleet would have required something audible over distance. A drum, perhaps, or a chanted call, or the clapping of hands, or a horn. There is a boat in the relief that appears to be leading, and it is easy, and probably not wrong, to imagine that its function was to give the stroke to the whole formation, and that the sound of it carried back over the water to 800 men who pulled when they heard it. The pull itself would not have been the frantic sprint of a race. It would have been slow, immensely slow, the long, heavy stroke of men moving a mass that accelerates almost imperceptibly, and then, once moving, refuses to stop. A loaded barge of that size has enormous momentum. Getting her underway from rest would have been the hardest part. The tow lines coming taut one after another, the boats digging in, the whole fleet straining, and then the first grudging meter, and then another, and then the slow establishment of a steady pace that could be maintained for hours. Stopping her would have been almost as difficult, and would have had to be planned long in advance, which is one reason why the pilots mattered so much. The current helped. This was a voyage downstream, northward, with the flow of the river, and that is not a small advantage. The Nile in flood runs at a useful speed, and a floating object placed in it will move north whether anyone rows or not. The towing fleet's job, in one sense, was not to move the barge but to control her, to keep her in the deep channel, to give her steerage way so that the rudder oars could bite, to hold her straight when the current tried to turn her, and to pull her clear when she threatened to drift toward a bank or a shoal. Towing on that river was as much about steering as about propulsion. But the current was also the danger. A river in flood is not a placid thing. It carries debris. It changes its channel. It runs faster on the outside of bends and piles water against the bank. And a heavy vessel caught in that set could be pushed aground before 800 oarsmen could do anything about it. And the Nile between Aswan and Thebes has sandbanks, and the sandbanks move from year to year. And a barge drawing perhaps 2 or 3 meters loaded would have found a good many of them if she had not been guided by men who knew exactly where the deep water lay. So there would have been pilots. There is no monument to them, no inscription naming them, but they must have existed. Rivermen, probably local, who had spent their lives on that stretch of water, who knew where the channel ran in a high year and where it ran in a low one, who could read the surface of the river and tell from a ripple what lay a meter beneath it. They would have gone ahead in small boats, sounding with poles, marking the way. The safety of the whole enormous enterprise, and of the Queen's monuments, and quite possibly of Senenmut's career, rested in the hands of men whose names no one bothered to write down. Around the working fleet there was, if the relief is read as a ceremonial as well as a practical document, something more. There are vessels that do not appear to be towing. There are figures who appear to be officiating. This was not merely a haulage operation. It was a sacred procession, the movement of the god's property toward the god's house. And it would have been accompanied by ritual, by offering, by the burning of incense and the recitation of formulae, and possibly by the presence of priests aboard the escorting boats. The Egyptians did not draw a firm line between engineering and religion. A thing was done well when it was done correctly, and doing it correctly included doing it with the proper words spoken at the proper moments. And along the banks there would have been people. This is the part of the story that the record does not contain, and that we can nevertheless be almost certain of. A vessel of that size, moving down the river with 2 obelisks on her deck and a fleet of towing boats ahead of her, and the sound of 800 oars, would have been the greatest spectacle those villages had ever seen or would ever see. The Nile was the highway, and the villages sat on its banks, and the people of those villages spent their whole lives watching boats go by. They knew every kind of vessel. They knew the fishing craft and the cargo boats and the ferries and the ceremonial barks of the gods. And then, one day, around a bend in the river, came this. They would have run to the water. Children would have followed along the bank for as far as their legs would carry them. Old men would have talked about it for the rest of their lives and told their grandchildren, and the grandchildren would have half believed them. And the barge would have come on, slowly, in the middle of the stream, sitting deep, with the granite lying along her deck, catching the sun, and passed and gone north. And the river would have closed behind her, and the village would have gone back to its work, and nothing like it would ever come by again. It is worth saying a word about the towing boats themselves, because they are easy to overlook beside the enormous hull they were pulling, and they were not trivial vessels. Each of them was a working river craft of the standard Egyptian type, and each carried a full crew of oarsmen, and to gather 27 of them in one place at one time, with their crews, and to hold them there for the duration of a voyage of weeks, was, in itself, a considerable act of requisition. These boats had other lives. They belonged to temples, or to the state, or to officials, and they were normally employed carrying grain and stone and cattle and people up and down the river in the ordinary business of the country. For the duration of the obelisk transport, all of that stopped for them. They were taken out of the economy and put on a rope. Their rowers were taken out of the economy too. Somewhere in the villages of Upper Egypt, for a season, there were fields being worked by fewer hands than usual, and boats not making their usual runs, because the men who normally did those things were on the river pulling a queen's monument. This is what it means for a state to mobilize. It is not a matter of ordering a thing to be done. It is a matter of accepting that a great deal of other work will not be done while it is happening, and being able to afford that. And Egypt in the middle of the 18th dynasty could afford it. And that fact is itself one of the more eloquent things this story tells us about the period. The boats were built the same way the barge was built, on a smaller scale. Shell first, planks joined edge to edge with tenons, no keel, a hull that could take the ground gently and float again, shallow of draught, broad of beam, with the characteristic upswept ends. They were rowed rather than paddled, with the oars working against thole pins or in loops of rope, and the rowers sat facing aft as rowers always have, and they were steered by great oars at the stern. Under sail they could make good speed upstream. Under oars, in a tow, they could pull. And the rope between them and the barge was, in its way, the single most critical component in the entire operation, and it is the one about which we know the least. Egyptian rope was made from vegetable fiber, most commonly from halfa grass, or from the fibers of the date palm, or from papyrus, and it was made well. Rope has been recovered from Egyptian sites in remarkable condition, and it is properly laid, with the strands twisted in one direction and the rope in the other, so that the whole thing locks itself under tension, exactly as rope has been made ever since. Very large ropes, thick as a man's arm, were made for hauling and for the hogging trusses of ships, but no ancient rope, however well made, has anything like the tensile strength of a modern steel cable, and the load in this case was extraordinary. The way you deal with that limitation is by multiplication. You do not use one rope, you use many, sharing the load, each one taking a portion, and you arrange them so that if one parts, the others hold. The tow lines from 27 boats, gathered to a common point, spread the strain across a great many separate fibers, and the redundancy is the safety. It is the same principle as the steering oars, and the same principle as the 800 men. When you can't make a single element strong enough, make a great many elements and let them work together. There is something almost philosophical in that, and it recurs throughout Egyptian engineering. They did not seek out the strongest possible material and rely upon it. They took ordinary materials, understood their limits precisely, and then arranged them in numbers sufficient to overcome those limits. Wood that could not span a great distance was joined into a shell. Rope that could not take the load was multiplied. Muscle that could not shift the weight was assembled in the hundreds and given a rhythm. Nothing in the entire system was individually remarkable. The system was remarkable, and the system moved, at last, and turned its bow to the north, and began the long descent to Thebes. The distance from the quarries at Aswan to Thebes is, in a straight line, something over 200 kilometers, and by the river, which bends, rather more. It is not a great distance by modern standards. A car covers it in a morning. But for a wooden barge under tow, moving at the pace of a slow walk, in a channel that had to be read meter by meter, and stopping every night, it was a voyage of weeks. They would not have traveled after dark. There is no reason to think they would have risked it, and every reason to think they would not. Night navigation on a river without lights, with sandbanks, with a vessel that cannot stop and cannot turn quickly, is an invitation to disaster. So the days would have had a shape, an early start in the cool of the morning, the slow business of getting the fleet underway, the long haul through the heat with the sun climbing, and the men at the oars pulling in silence or to a chanted rhythm, a pause perhaps in the worst of the afternoon, and then the approach to whatever mooring had been chosen, and the delicate, dangerous work of bringing the barge to rest without letting the current take her. Mooring 1,000 tons is not a matter of throwing a rope around a post. She would have been eased in toward the bank, or more likely held in a slack stretch of water, with lines out to both shores and to heavy anchors, and the towing boats standing by all night in case she began to move. Someone would have been awake at every hour, watching the lines, watching the water, listening to the hull. A ship carrying that load talks. Timber under stress creaks and clicks and complains, and the men aboard would have learned the particular voice of that hull very quickly, and would have known, without being able to explain how, when the sound changed. The land they passed through was familiar to all of them, and would be familiar to us. On both banks the cultivated strip, green and intensely worked, with irrigation channels and small fields, and the mud brick villages set back a little from the water. Beyond that, quite abruptly, the desert, and behind the desert the cliffs, pale in the morning and gold in the afternoon and rose-colored at evening. Palm groves, cattle at the water, herons standing in the shallows, fishermen with nets who would have pulled in hard toward the bank and stared, and then gone back to their nets. They would have passed the temple sites that were already old, and the ones that were still being built. They would have passed Kom Ombo and Edfu, where a great temple would rise long after all of them were dead, and Esna and Gebeline. They would have passed places whose names we no longer know. And every one of these places had a landing, and at every landing there would have been officials, because a royal expedition of this magnitude did not simply drift downstream. It was provisioned. 800 and more oarsmen, plus the crew of the barge, plus pilots and priests and overseers and scribes, is a small town, and a small town has to eat every day. Bread and beer, the two staples of Egyptian life, would have had to be produced somewhere and delivered somewhere, and the logistics of feeding a floating town moving slowly down a river would have been worked out in advance by men with reed pens. We have, from other periods and other projects, a sense of how such accounting looked. Rations issued in loaves, recorded by name of gang, days worked, days absent, and the reasons for absence, which in one famous set of records from a workman's village, include such items as brewing beer, attending a funeral, and being bitten by a scorpion. The clerks who recorded such things were not writing history. They were doing their jobs. But their jobs are the reason we can be confident that behind the grand image on the temple wall there was an ordinary, grinding, well-organized administrative machine, and that somebody every evening counted the bread. We should also consider what could have gone wrong, because the fact that the expedition succeeded should not make us forget how narrow the margin was. A tow line could part. Ropes of vegetable fiber, however well made, fail, and the failure of a tow line under full strain would have been violent. The rope would have come back like a whip, and men would have been hurt, and the boats ahead would have surged forward suddenly and perhaps fouled one another, and the barge, released, would have begun to drift. And the drifting of 1,000 tons in a current is a slow catastrophe that everyone can see coming and nobody can stop. The barge could ground. If she touched a sandbank, even gently, the current would push her stern around and she would swing broadside. And once broadside in a current, a vessel of that beam presents an enormous surface to the water and is pinned. To get her off would have required the removal of the load, and the removal of the load in the middle of a river is not possible, which means that grounding badly might well have meant the end of the project. Everything about the way the fleet was organized, the pilots ahead, the redundant steering oars, the sheer number of towing boats, speaks of an obsessive determination to prevent exactly that, and the hull could fail. There is no reason to suppose the shipwrights were confident. They had built something at the very limit of what their materials allowed, and every day at sea, or rather every day on the river, was a test of joints they could not inspect. Water in the bilges would have been baled continuously. Some leakage is normal in a wooden vessel. A change in the rate of leakage is a warning. and someone would have been watching for it. Nothing in the record suggests that any of these things happened. The inscription at Karnak speaks of success, and the obelisks are there, or were, and the story as Egypt chose to tell it is a story of triumph. But the Egyptians did not, as a rule, record failure on temple walls. If a barge had been lost, we would very likely never know. It is worth remembering that the unfinished obelisk lies in its quarry to this day as a monument to a project that did not work, and that it survives only because it was too heavy to remove and too ruined to use. Failure in ancient Egypt was usually invisible. And then, after weeks, the river brought them to Thebes. The approach would have been unmistakable. The valley opens out a little. The cliffs on the western side draw back into that great natural amphitheatre, where the tombs and the temples of the dead were being cut. And on the eastern bank, the city stood, and above the city, visible from far off, rose the pylons of the house of Amun. Karnak was already vast, and it was already old. Kings of previous dynasties had built there. Hatshepsut's own father had built there. And now the barge came down the last stretch of the river with the two obelisks on her deck, and the god's house waited for them. Getting her in was the last and one of the most delicate operations of the whole enterprise. Karnak stands back from the modern riverbank, and it stood back from the ancient one, and there is good evidence that it was served by a canal running in from the Nile to a basin or quay in front of the temple, so that the sacred barks could be brought in, and so that heavy cargo could be delivered where it was needed, rather than dragged a kilometre across the ground. Whether that canal existed in exactly the form we imagine at exactly this date is a question archaeologists continue to work on, but the principle is sound, and the Egyptians used it repeatedly. Water goes where you dig it. If you need a river at your temple door, you make one. So the barge, in all likelihood, was brought out of the main stream and into a cut and drawn up to a prepared bank. And there the whole process of loading was performed in reverse. If she had been floated up under the stone at Aswan by the rising of the water, then here the water had to fall, or be let out, or she had to be settled onto a prepared bed, so that her deck came level with a solid platform, and the obelisk could be drawn ashore horizontally, on its sledge, without ever being lifted. The timing of this against the season of the flood is another of those places where the calendar rules everything. The water is high for a limited period. It falls through the autumn and reaches its lowest in the spring. To use the flood at Aswan and again at Thebes, the whole voyage had to fit within the high water, and the unloading had to be accomplished before the level dropped too far. If the 7 months of the inscription mean anything at all, they may mean precisely this: that the project was governed by the river's timetable, and that everything, quarrying, hauling, building, loading, sailing, unloading, erecting, had to be crammed into the window the Nile allowed, and then the obelisks were ashore, and the barge, having done the thing she was built for, drops out of the story entirely. The final act took place on land, and it was in its own way the most dangerous part of all, because everything that had been accomplished so far could still be undone in a moment. An obelisk on its side is a slab of stone. An obelisk standing is a monument. The transformation between the two states requires that a shaft of granite, hundreds of tons in weight, be raised from the horizontal to the vertical and set down precisely on a base, without chipping its edges, without cracking its body, and without falling. To appreciate the difficulty, consider what is actually happening in the last stage of that movement. As the obelisk approaches the vertical, its center of gravity passes over its base, and at that moment, it stops being pulled up and starts wanting to fall the other way. If it is allowed to swing past the vertical, it will topple, and it will topple with the accumulated energy of hundreds of tons, and it will shatter, and the work of a year and the wealth of a province will be lying in pieces on the ground in front of the god's house, in public, in front of the priesthood, in front of the queen. The Egyptians left no description of how they did it. Not one. There is no relief showing an obelisk being erected, no text explaining the method, nothing. This is one of the great blank spaces in the history of technology, and into that blank space, generations of engineers have poured their ingenuity. The most influential proposal is again Engelbach's, and it depends on sand. In his reconstruction, the Egyptians built a great ramp of brick and rubble leading up to the site, and within the top of that ramp, they constructed a funnel-shaped pit, wide at the top and narrowing downward, filled with sand, with the base of the obelisk's pedestal already in position at the bottom of the shaft. The obelisk was dragged up the ramp, butt first, and its butt end was worked out over the sand-filled funnel. Then the sand was let out, through openings at the bottom, slowly, and as the sand drained away, the butt of the obelisk sank, gradually into the funnel, and the shaft tilted and continued to tilt until it was leaning steeply, at which point ropes from above could take the strain and bring it upright onto its base, and the last of the sand and the ramp could be dug away. It is an ingenious solution, and it uses a principle the Egyptians certainly understood: the controlled lowering of a mass by the removal of sand from beneath it. Whether it is what they actually did is unknown, and other engineers have proposed alternatives: levers and packing, raising the butt end by increments and inserting supports. A great ramp with the obelisk hauled up and tipped over an edge, a wooden cradle. The Roman architect Domenico Fontana, who moved and re-erected a great Egyptian obelisk in Rome many centuries later, used a forest of timber scaffolding, dozens of capstans, hundreds of men and horses, and iron fittings, none of which the Egyptians had. What is beyond doubt is that the Egyptians solved the problem, repeatedly over many centuries, for stones of increasing size, and did so with such reliability that obelisks went on being raised for 2,000 years. And there is a piece of evidence that suggests they were doing something clever at the very moment of setting the stone down. The base of an obelisk and the pedestal it stands on are enormously heavy, and yet the fit between them had to be precise. Some surviving pedestals show a small step or lip, and some show a slot at one corner. One suggestion is that the butt of the obelisk was brought down so that one edge caught in such a slot, giving it a pivot, so that the last movement into the upright was a rotation about a fixed point rather than a slide. It is a small thing, an inch of stone in the corner of a block, and it may be the fingerprint of an engineer. Once upright, the obelisk stood by its own weight. Nothing held it. There was no mortar of any consequence, no clamp, no fastening. 300 tons of granite balanced on a base, and it has stayed there through earthquakes and floods and the collapse of the civilization that raised it for 35 centuries. The pair went up in the great hall at Karnak, between two pylons that Hatshepsut's father had raised, in a space that had been roofed and colonnaded, and there is some evidence that the roof and part of the colonnade had to be dismantled or modified to get them in and to let them stand clear, which, if true, is an astonishing detail. It means that the queen was willing to take the roof off her own father's hall in order to make room for her gift. The obelisks were taller than the building. Something had to give. And then the tips were sheathed. The inscription speaks of the finest electrum, that alloy of gold and silver, applied to the pyramidions, and it speaks of the quantity in terms that were meant to impress. The metal was probably worked into sheets and fitted over the stone and fastened, and there is evidence on some obelisks of the cuttings that held such sheathing in place. And when the sun rose over the eastern desert, the first light of the day would strike those 2 points of bright metal, high above the roof of the temple, before it touched anything else in Thebes. That was the purpose. All of it, the pounding in the quarry, the trench, the sledge, the barge, the 800 oarsmen, the weeks on the river, the sand and the ramp and the ropes. All of it existed so that the sun would have something to land on when it came up over the hills, and so that the god would know he had been remembered. The inscription on the base makes a claim about that too. It says the obelisks were made for Amun, and it says they were made of a single block each, of enduring granite, and it insists on the sincerity of the gift. And then, in a passage that has become famous, it speaks to those who will see them in the future, and says that they should not doubt, and that the queen did not speak boastfully, but did what she said she would do. 3,500 years later, one of them is still standing exactly where she put it, and people come from all over the world to look up at it. And it is very difficult, standing in its shadow, not to concede the point. The barge did not exist in isolation. She belonged to a tradition, and it is worth pausing here in the long, quiet middle of the story to look at the other great ships that stand on either side of her in time, because the impulse that built her is one of the most persistent impulses in human history. And it did not begin with Hatshepsut, and it certainly did not end with her. Behind her, by more than 1,000 years, lay the ships of the Pyramid Age. The vessel found buried beside the Great Pyramid, the one lifted piece by piece out of its sealed pit in the 1950s, is the finest surviving example, but it was not alone. A second pit lay beside it, and it too held a dismantled ship, and the excavation of that second vessel occupied conservators for decades. At Abydos, far to the south, archaeologists found a row of boat graves, brick-built, each containing the remains of a wooden vessel, and these were older still, dating to the very first dynasties, near the beginning of Egyptian history. At Dashur, boats were found near the pyramid of a Middle Kingdom king, and they are now scattered among museums in several countries. Egypt buried ships the way other cultures buried horses, and the reason was religious. The dead king had journeys to make, and journeys were made by water. Behind her also lay a memory, recorded on a fragmentary stone annal, of a king of the Old Kingdom, Sneferu, who is said to have had built a ship of 100 cubits, which is to say something over 50 meters, and given it a name that meant, more or less, praise of the two lands. That is a very early date for a vessel of that size, and the entry is terse, and we would give a great deal to know more. But it establishes that even in the age of the pyramid builders, the Egyptian state was capable of thinking on that scale, and cared enough about it to write it down. And beside her, in her own reign, on the very same wall of the very same temple, lay another fleet, and that fleet went to sea. The expedition to Punt is the other great maritime narrative Hatshepsut left behind. Punt was a land somewhere to the south and east, reached by way of the Red Sea, probably in the region of the coast of what is now Eritrea or Sudan, or perhaps the Somali coast, though its exact location has never been settled, and the debate has run for as long as the debate about the barge. It was the source of incense, of myrrh and frankincense, of ebony and ivory and gold and exotic animals, and it had a mythic quality in the Egyptian imagination, a place at the edge of the known world from which precious things came. The reliefs show 5 ships, seagoing vessels, quite different from rivercraft, with a single mast and a broad sail and a hull of a shape adapted for open water, and they show them loading at Punt with an almost inventory-like precision. The sacks of incense, the heaps of resin, the animals, and, most memorably, living myrrh trees with their root balls carefully bound in matting, carried aboard on poles by teams of men. The reliefs show the Puntites, their houses on stilts, their ruler, and his wife, whose portrait is one of the most discussed images in Egyptian art. And they show the ships returning, and the cargo being presented, and the trees being planted in the terraces of the temple itself, where the pits that held them have been found. Those ships had to be built too, and getting a seagoing fleet onto the Red Sea from a country whose life ran along a river was itself a considerable feat of organization. The evidence suggests the Egyptians did it by carrying their ships in pieces across the desert to a harbor on the Red Sea coast, assembling them there, sailing, returning, disassembling them, and carrying the components back to be stored for the next expedition. Remarkable confirmation of this came from a site on the Red Sea coast, where excavation revealed man-made caves cut into the rock, and in them, stored and stacked, were ship timbers, cedar planks bearing the marks of mortise and tenon joinery, cargo boxes, coils of rope still in their loops, and inscriptions naming Punt. The rope had not been touched for nearly 4,000 years, and it was still coiled where the last man to use it had left it. That, more than any relief, is what the world of the barge actually felt like. Rope in a cave, timber stacked and numbered. A state that thought in terms of components and storage and reuse, that took its ships apart and carried them over mountains and put them together again on a different sea. Ahead of her in time lay the long afterlife of the obelisk, and that afterlife is, improbably, mostly a story about ships. Because the strange fate of Egyptian obelisks is that they did not stay in Egypt. They were too impressive to leave alone. Empire after empire, arriving in the Nile Valley and finding these enormous, ancient, incomprehensible fingers of stone standing in front of temples, had the same reaction, which was to want one and to take it home. And the taking home was always, without exception, a maritime problem, and it always required a ship built or adapted for the purpose. And so the barge of Hatshepsut has descendants, and they run all the way down to the age of steam. The Roman writer Pliny, compiling his enormous natural history in the 1st century of our era, devoted a passage to obelisks, and he was interested, as an educated Roman would be, in the mechanics of the thing. He describes how the Egyptians transported them, and he describes a method that will sound familiar: the digging of a canal beneath or beside the recumbent obelisk, the bringing in of vessels, the use of the water to lift the stone by floating the boats under it. Pliny was writing many centuries after Hatshepsut, and he was working from sources we no longer have, and whether his description reflects the practice of the New Kingdom or a later Ptolemaic method is impossible to know. But it is striking that the principle he describes, the use of buoyancy rather than lifting, is exactly the principle the modern reconstructions independently arrived at. The Romans, who had cranes and had studied the problem, concluded that the way to move an obelisk was to let the river do the lifting. It is hard to imagine better testimony to the intelligence of the original solution. Pliny also tells us something about the ship that brought a particular obelisk to Rome under the Emperor Caligula. It was, he says, a vessel of astonishing size, the most remarkable ship ever seen at sea, and he describes the timber of its mast, and he mentions, in a detail that has fascinated readers ever since, that the ballast or packing that filled its hold was measured in an enormous quantity of lentils. Why lentils? Presumably because they are small and dense and pour like liquid, filling every gap and cushioning the load, and because they could be sold or eaten afterwards. It is one of those details that could not possibly be invented. That ship, having delivered its obelisk, did not sail away. According to the accounts, the Emperor Claudius had it filled with concrete and sunk to form part of the foundation of a new harbour mole at Portus, at the mouth of the Tiber. And in the 20th century, excavation at that site revealed the remains of a very large ancient hull beneath the harbour works, which many have taken to be that very vessel, though the identification is not certain and the matter continues to be discussed. If it is the ship, then it means that the greatest obelisk carrier of the Roman world ended its life as a lump of masonry in a breakwater, holding back the sea for centuries after everyone had forgotten what it was. The obelisk it carried, by the way, is still standing. It stands in the middle of the piazza in front of the Basilica of St. Peter in Rome, and it is uninscribed, and it has stood in the city in one place or another since the reign of Caligula, and it is the only ancient obelisk in Rome that never fell. There is another, and it is larger, and it has the most direct connection to our story of any object in Europe. The obelisk that now stands before the Basilica of St. John Lateran in Rome is the tallest ancient obelisk in the world. It rises to something over 32 meters of granite, and it weighs, by most estimates, in the region of 450 tons or more. It was quarried at Aswan from the same granite, and it was made for Karnak, and it was begun in the reign of Thutmose III, Hatshepsut's stepson, the boy who grew up while she ruled and who became a king of extraordinary energy after her. He did not live to see it raised. It stood for a while unfinished, and it was eventually erected by his grandson, and it stood at Karnak for centuries. And then Rome came. The Emperor Constantine, in the 4th century of our era, decided that this obelisk should be brought to his capital, and had it taken down and carried to Alexandria, where it waited. Constantine died before it could be shipped, and his son Constantius, some years later, completed the project and had the stone brought across the Mediterranean and up the Tiber and set up in the Circus Maximus. We have an eyewitness account, or something very close to one. The historian Ammianus Marcellinus, writing in the same century, describes the operation. He describes the vessel built to carry it, a ship of a size that had never been seen, and he says it was rowed by 300 oarsmen. He describes the difficulty of bringing it up the river to the city and the transfer to a smaller vessel, and the hauling of the stone overland and the erection, which was accomplished with a vast forest of beams and ropes and an enormous number of men working capstans. And he says that when the obelisk rose, it seemed as if the sky itself were being lifted. 300 oarsmen, Hatshepsut's fleet, if the relief is read as most scholars read it, employed something in the region of 850. The Romans, with better tools, more metal, and 1,000 years of additional accumulated technology, needed a smaller crew for a smaller stone over a longer distance, which is a reminder that the comparison is not straightforward and that the Egyptians were solving a different problem in a different medium. But there is a continuity here that is quite moving when you look at it directly. The same granite, the same quarry, the same fundamental difficulty, the same solution, which is always, in the end, a ship. The Lateran obelisk fell, eventually, when Rome fell, and lay buried and broken in the mud of the Circus Maximus for something like 1,000 years. And then, in the late 16th century, it was dug up. The man who dug it up, and who raised it again, was an architect named Domenico Fontana, and his work on the obelisks of Rome is one of the great episodes in the history of engineering. And it is the moment when the ancient problem was solved again, from scratch, by people who had entirely forgotten how the Egyptians had done it. Fontana's most famous operation came first, and it concerned the uninscribed obelisk of the Vatican, the one Caligula had brought, which was still standing where the Romans had left it, but in an awkward position beside the old basilica. The Pope wanted it moved into the center of the new square. It had to be lowered, transported a few hundred meters, and raised again, and it weighed well over 300 tons, and nobody in Europe had done anything remotely like it within living memory or within any memory at all. Fontana built a structure of timber around the standing obelisk that came to be called the Castello, a great cage of beams. He wrapped the stone in matting and iron bands. He assembled dozens of capstans, and to the capstans he harnessed hundreds of men and scores of horses. And he worked out the load on every rope and the sequence of every movement. And on the day of the lowering, it is said, he had it announced that anyone who spoke aloud during the operation would be put to death, because the signals had to be given by trumpet and the men had to hear them. There is a well-known story, almost certainly a legend and repeated for centuries, that at the critical moment the ropes began to smoke from friction, and a sailor in the crowd shouted out to wet the ropes, and thereby saved the day and was rewarded rather than executed. The story is charming and there is no good evidence for it, and it has been told so often that it has become part of the monument. What is not legend is that Fontana succeeded, and that he then went on to raise the Lateran obelisk and others, and that he published a book describing his methods with engravings, and that his book was read for centuries. It took him months and enormous resources and an entire specialized apparatus, and he had iron and pulleys and the accumulated mechanical theory of the Renaissance, and he was moving a stone that had already been quarried, shaped, transported across the Mediterranean and erected once before by someone else. The Egyptians had to do all of it, and they did it, as far as we can tell, with rope, wood, sand, and an enormous number of extremely well-organized people. It does not diminish Fontana to say so. It simply puts him in a line. That line runs on into the 19th century, and there it becomes, once again, unmistakably a story about ships, and about the risks of moving stone on water, and about the fact that the risk never went away, no matter how good the engineering became. In the 1830s, the French set out to bring an obelisk from Luxor to Paris. It was one of a pair standing before the temple, and it had been given to France by the ruler of Egypt, and the problem was purely and entirely a transport problem. So they built a ship for it. She was named for the place the stone came from, and she was designed specifically for the job. Flat-bottomed enough to come up the Nile and strong enough to cross the sea, with a bow that could be opened so the obelisk could be slid in lengthwise. An engineer took charge of the operation, and he lowered the obelisk at Luxor and loaded it and waited for the flood and brought the ship down the river and across the Mediterranean and up the Atlantic coast and up the Seine, and the whole business took years. And then the obelisk was raised in the Place de la Concorde, in front of an enormous crowd, with the king watching, using a system of capstans and scaffolding that Fontana would have recognized immediately. It stands there now, in the middle of the traffic, and most of the people driving around it have no idea what it is or what it cost to bring. The British had an obelisk too, one of a pair that had stood at Alexandria and that had been given to Britain, and it lay on the ground there for decades because no one could work out how to move it or was willing to pay for it. Eventually, a private benefactor funded the attempt, and the solution devised was extraordinary. Rather than build a ship and put the obelisk inside it, they built a ship around the obelisk. A great iron cylinder was constructed on the beach, encasing the stone, fitted with a keel and a rudder, and a small deckhouse and bilge keels to steady it. And this cylinder was rolled into the sea and became a vessel in its own right, and it was named for the queen the obelisk was popularly associated with, and it was taken in tow by a steamer bound for England. In the Bay of Biscay they met a storm. The cylinder, under tow, began to roll violently, and the ballast inside her shifted, and she took a heavy list, and the men aboard her signaled for help. The steamer sent a boat, and the boat was lost, with all 6 of the men in it, trying to reach her. The crew of the cylinder were eventually taken off, and the tow was slipped, and the vessel with the obelisk inside her was abandoned in the Atlantic and given up for lost. 6 men died. Their names are recorded on a plaque at the foot of the obelisk today, on the embankment beside the river in London. And it is worth reading because it is the only place in this entire long history where the cost of moving one of these stones is written down in the form of a list of people. The cylinder did not sink. She was found, days later, drifting by a passing steamer, and taken in and salvaged, and eventually brought to England, and the obelisk was raised beside the Thames, where it stands, blackened by a century and a half of city air, with the scars of a bombing on its pedestal, quietly enduring, as it has endured everything else. And in America, a naval officer bought and moved the pair to the London Stone and brought it to New York in the hold of a steamer, having got it aboard by cutting an opening in the hull, and he raised it in Central Park, and he wrote a book about it, and he had a very high opinion of his own achievement, and he was, in fairness, entitled to it. 4 cities, 4 obelisks, 4 ships built or adapted for the purpose, thousands of years after the first one. And in every case, the same fundamental discovery arrived at independently. That stone of that weight cannot be lifted, but it can be floated, and that the sea, which is the most dangerous road in the world, is also the only one wide enough. And still, in all that long history, no vessel was built for the task that was quite as improbable as the first one. And when they stood, there would have been a ceremony. We do not have the text of it, not for this occasion, but we know a great deal about how Egyptian temples worked and what happened in them. And we can say with some confidence what kind of event the dedication of 2 obelisks would have been. It would have been a festival. Thebes had many, and they were the great public moments of the religious year, when the god came out of the darkness of his sanctuary and moved through the city. On ordinary days, the statue of Amun was hidden, tended by priests in a small dark room at the heart of the temple, washed and clothed and fed, and seen by almost no one. But on festival days he was placed in a portable shrine, a bark, a model boat carried on poles on the shoulders of priests, and he came out into the light, and the people saw the shrine, if not the god inside it. And the shrine moved through the courts and out of the temple and along the processional ways. And there was music, and there were singers, and there were offerings, and there was, presumably, an enormous amount of food and drink distributed, because that is how festivals work everywhere. That the god traveled by boat, even on land, even when carried by men on their shoulders through a courtyard, tells you everything about how deeply the river had entered the Egyptian imagination. The sacred bark was a ship. The sun crossed the sky in a ship. The dead journeyed in ships. When the god went from one temple to another, he went, when possible, on an actual vessel, on the actual Nile, in a great river procession with the banks lined with people. And on the wall of the temple across the water, the queen had caused to be carved the image of another ship, carrying another kind of offering, and the 2 things were not separate in the minds of the people who saw them. It was all one motion. The god comes by water, the gift comes by water, the sun comes up over the water in the morning. So the obelisks would have been dedicated in the presence of the god, and the queen would have been there, in whatever regalia the occasion demanded, and the priests would have recited the formulas, and the offerings would have been laid out, and the electrum on the pyramidions would have been new and bright, and, in that climate, in that light, almost impossible to look at directly. And somewhere in the crowd, or perhaps not in the crowd at all, perhaps in his own household, exhausted, there would have been Senenmut, who had conducted the work of the 2 great obelisks, and said so, in writing, in his own tomb, because he was proud of it and wanted it known. And somewhere on the river, at her moorings, empty now, riding high in the water without her cargo, sat the barge. Nobody, in all likelihood, gave her a thought. The stone was up. The god was pleased. The queen was vindicated. The ship had done her work and was simply a large object taking up space at a quay, and the men who had built her had gone home, and the men who had sailed her had been paid and released, and the rope was being coiled and stored, and the season was turning, and the water was beginning, very slowly to fall. So what happened to her? The barge delivered her cargo, and after that the record is simply blank. There is no inscription describing her retirement. There is no scene showing her being broken up. There is not so much as a stray administrative note recording that a large vessel was laid up in such and such a place, in such and such a year. She served, and then she vanished, and the manner of her vanishing has to be reconstructed from what we know about the fate of wooden ships in general, and Egyptian wooden ships in particular. The likeliest answer is the least dramatic one, and it is that she was taken apart. Timber in Egypt was precious. It was scarce. It was expensive. Much of the good material was imported from a great distance, and it was never, ever thrown away. Every excavation of an Egyptian settlement or workshop turns up evidence of wood being reused, patched, cut down, repurposed, and used again. Coffins were made from recycled boat planks. Boat planks were made from recycled coffins. Beams that had held up one roof were pulled out and put into another. The idea that a vessel containing many tons of imported cedar would simply be left to rot on a bank is very nearly unthinkable. And she had, after all, done what she was built to do. If she was constructed for a single specific commission, and if there was no other cargo in Egypt that required a hull of that size, then she was, the moment the second obelisk came ashore, an enormous and expensive object with no further purpose, occupying a berth, needing maintenance, drying and cracking in the sun. A wooden ship out of use does not keep. She works loose, her joints open, her fastenings fail. So we may reasonably picture, over the years following the Great Voyage, a slow undoing. The rigging and the ropes taken off first and stored, because good rope is valuable. Then the steering gear, then the deck beams, then the planking, prized apart at the tenons, the pieces stacked and sorted and carried away to other yards and other projects. Cedar from that hull may well have ended up in the roof of a house, in the frame of a door, in a coffin, in another boat. It may have been used in fragments for a century. And the last of it, the pieces too small or too broken to be worth anything, would have gone eventually into a fire. There is something appropriate in that, though it takes a moment to see it. The obelisks were made of the most permanent material available on Earth, precisely because they were meant to last forever. The ship that carried them was made of the most perishable, and was never meant to last at all. She was, in the deepest sense, a means. Everything about her was subordinated to the object she carried, and when the object was in place, she had no reason to continue existing. The Egyptians would not have found this sad. They would have found it correct. But there is a second possibility, and it deserves a hearing, and it is more speculative and rather more haunting. She may have sunk, not necessarily on the Great Voyage, which the inscriptions imply was a success, but afterwards in some subsequent employment, on some other errand, or simply at her moorings in a high flood with nobody watching. Wooden ships sink all the time, and they sink most often when they are old and neglected and no longer important to anyone. If she went down in a channel of the Nile, then she is still there. She is buried under silt, quite possibly a considerable depth of it, quite possibly under agricultural land where the river no longer runs, because the Nile has shifted its bed many times in 3,000 years. And vast areas of the modern floodplain were once river and are now fields. Egyptian riverine archaeology is difficult, and it is young, and it has produced some genuine surprises. Ancient harbors have been located under farmland. Sunken cities have been found in the delta and off the coast. Whole towns that subsided into the sea and lay there forgotten until sonar and divers found them in the last few decades. A submerged port with dozens of wrecks was discovered in the bay near Alexandria, and among them were vessels of a type known previously only from a description by an ancient Greek historian, which had been doubted for centuries and was then confirmed in a single excavation by a hull lying in the mud exactly as he had described it. That is the kind of thing that keeps archaeologists patient. It is not impossible that somewhere, under some field, under some many meters of silt, there lie the flattened timbers of an unusually wide hull, with mortise and tenon joints, of a size that would immediately tell anyone who found them what they were looking at. It is unlikely, but it is not impossible, and the discovery of the Punt expedition's rope, still coiled in its cave, should teach us not to be too confident about what Egypt has finished giving up. For now, though, she survives only on the wall, and the wall itself has a story, and it is a story of destruction and then of long, careful recovery. Hatshepsut died, and her stepson Thutmose III at last ruled alone, and he ruled magnificently. He led campaign after campaign into the Levant. He expanded Egyptian power to its greatest extent. He built prodigiously, and he was, by any measure, one of the most capable rulers Egypt ever had. And at some point during his long sole reign, something happened to Hatshepsut's monuments. Her images were attacked. Her statues were pulled down, smashed, and thrown into pits. Her name was hacked out of inscriptions, chiseled away from cartouches, removed from the lists of kings that later generations compiled. In her own temple, her figures were erased and replaced. Where she was depicted as a king, she was often removed, and the space filled with an offering table or with the figure of another ruler. It was not total. It was not perfectly systematic. Some images survived, in places difficult to reach, in places nobody thought to check. But it was extensive enough that for a very long time the ancient Egyptians themselves lost track of her, and later king lists simply do not have her in them, as though the throne had passed directly from her husband to her stepson, with nothing in between. The obvious explanation, and the one that dominated for a century, was hatred. Thutmose III, the story went, had spent his youth in the shadow of a usurping stepmother, and when she was finally gone, he took his revenge and set out to erase her from history. That story has largely collapsed, and its collapse is one of the better examples of how careful work changes a field. The problem with the revenge theory is chronology. Careful examination of the erasures and of the reigns of the monuments that overlie them indicates that the attack on Hatshepsut's memory did not begin immediately after her death. It appears to have begun a considerable time later, perhaps 2 decades into her stepson's sole reign, when he was an established and elderly monarch with a lifetime of victories behind him and nothing whatever to prove. Personal rage does not usually wait 20 years. What replaces it is something more political and, in a way, colder. The erasure may have had to do with the succession. Thutmose III had a son whom he wished to see follow him, and the existence, in the public record, of a woman who had taken the throne from a regency and held it, was a precedent that a careful king might prefer not to leave lying about. Removing her was not vengeance but housekeeping. It was the tidying of the record so that the line of legitimate kingship ran cleanly from father to son to grandson, without an awkward and irregular figure standing in the middle of it, showing everyone that such a thing was possible. Whatever the motive, the effect on our story is direct, because it is the reason one of her obelisks fell, and the reason the other survived in such a curious condition. At Karnak, around the base of the standing obelisk, a masonry wall was built. It rose to a considerable height, screening the lower part of the shaft, hiding the inscriptions, hiding the images of Hatshepsut being blessed by the god. The obelisk itself was not attacked. It was too big to remove, and it had been dedicated to Amun, and to smash a gift to the god would have been an offense against the god rather than against the woman who gave it. So instead, the gift was allowed to stand, and the giver was concealed. The upper portion of the shaft, high above the walls, could not be hidden, and there the inscriptions and images remained visible, and there they remain to this day. And that, ironically, is why we can read them. The wall that was meant to erase her protected the lower inscriptions from weather and from later damage for centuries. And when it was eventually removed, the carvings underneath were found in better condition than the exposed portions above. There is a lesson in that which the queen, who wrote so anxiously about how the future would judge her, might have appreciated. The attempt to hide her was the reason her words survived. Her second obelisk did not survive standing. It came down at some point, in some way, whether by earthquake or by structural failure, or by human action. Its upper portion, including its pyramidion, lies at Karnak now, on its side near the sacred lake, resting on a modern support, and you can walk up to it and put your hand on the granite and look closely at the carving, which is exquisite. The lines are crisp, the figures are precise. It has been lying on the ground for a very long time, and it has not lost its edges, because granite does not lose its edges, and that is exactly why they chose it. The rediscovery of all this took a long time, and it happened in stages, and it was neither tidy nor especially heroic, and it was carried out by an assortment of people whose motives ranged from scholarship to acquisition. Thebes had never been entirely lost. Karnak was too large to disappear. Travelers had seen it and drawn it and marveled at it for centuries, and the standing obelisk of a queen whose name nobody could read was a landmark long before anyone knew who had raised it. But the temple across the river, the terraced temple against the cliffs where the story of the barge was carved, was buried. Sand had drifted into it. A Coptic monastery had been built over part of it, which is where the modern name of the site comes from. Its walls were half hidden, and its reliefs were choked with debris. The clearance of it occupied a succession of excavators through the 19th century and into the 20th. Auguste Mariette worked there. Later, the Egypt Exploration Fund sponsored a long and systematic campaign under a Swiss Egyptologist named Edouard Naville, and it was that campaign, running through the 1890s, which cleared the temple properly and published its reliefs, including the Punt scenes and the Obelisk transport scene, in a series of large volumes that put the images before scholars for the first time in a usable form. Later still, in the earlier 20th century, an American expedition from the Metropolitan Museum under Herbert Winlock spent season after season in the same bay of cliffs. It was Winlock's team, digging in a quarry and a pit near the temple, that found the smashed statues, hundreds of fragments of the Queen's images, deliberately broken and dumped. And it was the slow work of matching those fragments and reassembling them that gave us back her face, or rather, gave us back the several different faces her sculptors gave her, some idealized and feminine, some carved with the full regalia and the ceremonial beard of a king. And it was in this period, too, that the engineers arrived and began to argue. Reginald Engelbach, working at Aswan, studied the unfinished obelisk, measured the pounding marks, calculated the volumes, and published his conclusions. He was interested in what could actually be done with the tools available, and he was, by temperament, skeptical of easy answers. He proposed the sand funnel method for erection, and he thought seriously about the barge, and he arrived at figures for its size that were larger than many people wanted to accept. His work is nearly a century old now, and much of it has been revised. But the questions he asked are still the questions. Others followed. Naval historians produced reconstructions, and the reconstructions disagreed, and the disagreement clarified where the real uncertainties lay. Some argued for a single vessel of enormous beam. Some argued the artist had combined two voyages. Some proposed that the obelisks had never been carried on a deck at all, but slung or floated between paired hulls, in an arrangement that got the buoyancy where it was needed without asking the timber to do anything it couldn't do. Every one of these proposals is an attempt to answer the same stubborn question. How do you make wood carry stone? And in the last decades of the 20th century, people began to try it, physically, for real. There have been several attempts to reproduce ancient stone-moving methods with authentic materials, some of them for television, some of them purely for research. Teams have dragged multi-ton blocks on wooden sledges over wetted surfaces and found that it works, and works better than expected, and that the number of men required is smaller than intuition suggests. Others have attempted to raise obelisks. One well-publicized effort in the 1990s, involving an experienced stonemason and an archaeologist, tried to erect a substantial obelisk using ropes and a ramp and a levering system, and it failed. And the failure was instructive because it demonstrated exactly how narrow the tolerances were and how easily a stone of that size can jam or slip or lodge itself at an angle from which it cannot be recovered. A later attempt, with a smaller stone and a sand-filled chamber of the kind Engelbach had imagined, succeeded, and the stone came upright, and everyone watching understood, for a moment, what it might have felt like. What all of this experimental work has established, more than any specific technique, is a kind of respect. The methods available to the Egyptians were sufficient. They were not tricks, and they were not lost secrets. They were rope, wood, stone, sand, water, and organization. And the last of these was the most important. What the Egyptians had that we find hardest to reproduce is not a technology. It is a workforce of thousands, trained, provisioned, disciplined, and available, and a state capable of directing that workforce at a single object for a year, and a culture in which everyone involved understood why it mattered. And that, in the end, may be the true answer to the question of how the barge was built and how she carried what she carried. Not a clever joint, not a hidden principle, just an enormous number of people who knew what they were doing, working together on a river for a god. Stand today in the Great Hall at Karnak, in the space between the pylons, and look up. The obelisk is there. It has not moved. It was set on its base by men who spoke a language nobody has spoken as a mother tongue for a very long time, who worshipped gods whose temples are ruins, who served a queen whose name was chiseled off the walls and forgotten for 30 centuries. And it has stood in that exact spot, in that exact posture, while everything else changed. It has stood through the reigns of the rest of the 18th dynasty. It stood while a later king abandoned Amun altogether, moved the capital, and tried to replace the entire religion of Egypt with the worship of the sun disk. And it stood while that experiment collapsed, and the priests came back, and the old names were restored. It stood while Rameses raised his monuments, and fought his battles, and wrote about them at very great length. It stood through the long, slow decline, through the division of the country, through the Libyan kings and the Nubian kings and the Assyrian invasion. It stood when the Persians came. It stood when Alexander came, and when the Ptolemies ruled from the north and spoke Greek and put their names in cartouches anyway. It stood when Rome took Egypt, and when the Romans began carrying obelisks away across the sea. It stood while the temple around it fell out of use, while the last priest of Amun performed the last rite and went home, while the knowledge of how to read the inscriptions carved on its own flanks was lost entirely, so that for centuries the writing on it was simply a pattern, beautiful and mute. It stood while a monastery was built in the ruins across the river. It stood while the sand came in. It stood through earthquakes that brought down its companion and toppled columns all around it. It stood while the villages came and went, while Napoleon's scholars measured it and drew it, while a Frenchman deciphered the script and the stone began, quite suddenly, to speak again. It stood while excavators cleared the debris from around its feet and found the wall that had been built to hide the woman's name, and took the wall down and read what she had written. And it is standing now, this morning, as it has every morning. And when the sun comes up over the eastern hills, the light reaches the top of it first, exactly as it was designed to, though the electrum is long gone, stripped away for its value at some unrecorded moment by people whose names we will never know and whose need was probably real. The gold is gone. The queen is gone. The god, in the sense in which they meant it, is gone. The stone remains, and the stone is doing precisely what it was put there to do, and the ship that brought it is not there at all. That asymmetry is, in the end, the heart of this story, and it is worth sitting with, because it says something quite particular about the way human beings make things. We build two kinds of objects. There are the objects we intend to last, into which we pour our best material and our deepest care, and all our hope of being remembered. And there are the objects we build in order to make the first kind possible. And these we build out of whatever is to hand. And we use them hard, and we take them apart when we are done, and we do not think about them again. Every monument in the world stands on top of a hidden machinery of the second kind. Every cathedral had scaffolding. Every pyramid had a ramp. Every bridge had a falsework, a temporary structure that held the stone in place until the stone could hold itself, and then was struck away and burned. The temporary thing is always more ingenious than the permanent thing, because the permanent thing only has to stand there, whereas the temporary thing has to solve the problem. The barge was falsework. She was the most sophisticated object in the entire enterprise, more difficult to design than the obelisk, more dependent on judgment, more vulnerable, more likely to fail. The obelisk, once shaped, was simply a very large piece of rock, and rock is patient and requires nothing. The ship had to float. She had to float under a load that ought to have broken her, and she had to keep floating for weeks, and then, having succeeded, she became worthless in the same instant and was picked apart for her timber. And yet, somehow, someone thought she was worth drawing. That is the thing that saves this story from being merely a story about engineering. Somebody, in the planning of that temple, in the decision about what would go on those walls, decided that the ship mattered. They could have shown only the obelisks standing at Karnak, gleaming, finished, offered to the god. That would have been the natural choice. That is what the monument was for. Instead, they gave a long stretch of wall to the process, to the transport, to the barge and the towing boats and the ranks of oarsmen, to the labor and the ingenuity and the sheer difficulty of it. They chose to record not just the gift, but the giving. And because they made that choice, the ship exists. She exists in the only way she could possibly have survived, which is as an image, cut into limestone by a craftsman whose name is also unknown, working from either direct observation or from a plan, or from the descriptions of men who had been there. He drew what he had been told to draw, and he drew it carefully. And every reconstruction, every calculation, every argument about her beam and her displacement and her hogging truss for the past 150 years has been an argument about the marks that man made on a wall. He is the last link in the chain. Without him, we would not know she had ever existed. There would simply be two obelisks at Karnak, and a mystery about how they got there, and a series of guesses. There is one more thing to say about the men whose names we do not have, and then we can let the river carry us out. We know Hatshepsut, we know Senenmut, at least by title and by ambition, and by the small hidden images he had carved of himself in the queen's own temple. We know Thutmose III, and we know something of the men who cleared the sand 3,000 years later, and the men who argued about the barge in learned journals. We do not know the master shipwright. We do not know the man who worked out that the hull needed to be that wide, or the man who decided how many steering oars would be enough, or the man who calculated, by whatever means he had, how deep the trench needed to be. We do not know the pilot who stood in the bow with a sounding pole and read the river. We do not know the man who called the stroke for 800 oarsmen and kept them together for hours in the heat. We do not know the quarryman who first noticed the crack in the great unfinished obelisk and had to go and tell his overseer. And we do not know what was said. We do not know the name of a single one of the oarsmen, not one, out of the many hundreds who pulled that stone down the river. They were there. They existed as fully and as particularly as anyone reading this. They had families and preferences and aching shoulders and opinions about their overseers. They ate bread and drank beer and slept, most of them, on the ground beside the water. Some of them were probably frightened, at least once, when the barge did something unexpected. Some of them, on the last day, when the granite came ashore at Thebes and the thing was done, must have felt something very like pride and had no way to record it, and told their children instead, and the children told theirs, and it faded, as everything spoken fades, within 100 years. The obelisk is their monument, whether or not it was meant to be. It is the only object in the world that could not exist without them. Every meter of its height is the height of their labor, and it is standing. The wind moves through the ruins at Karnak in the evening, and the swifts come out and turn above the columns, and the shadow of the obelisk lies long across the stones, pointing east, the way it has pointed every evening for 3,500 years. And on the other side of the river, in the temple against the cliffs, in the quiet colonnade where the tourists thin out toward the end of the day, the barge is still there on the wall. She is still under tow. Her oarsmen are still pulling in their ranks, in their stacked rows, in the endless present tense of Egyptian art, and they will never arrive, and they will never stop. And the two obelisks lie along her deck as they lay on the day she was drawn, and the water she floats on is a band of zigzag lines cut into the limestone, and it will never run dry. There is no wreck to find. There may never be. Somewhere under the fields of the Nile Valley, or somewhere in the ash of a fire lit 34 centuries ago to cook a meal for a family whose name is gone, is the last of that cedar. It does not matter very much. She did what she was built for. She carried the mountain. If you have found something here worth staying for, you might follow this channel, where other great ships wait, other harbors, other quiet water. There is no need to do anything now. Let the river run north in the dark, and the oars go on, and the stone lie easy on the deck, and let yourself drift with them, slowly, all the way down